Hello, welcome. In this short video, let us look at the basic inequalities in probability theory. So the first theorem we want to look at is the probability of A intersection B is less than or equal to probability of A. So from basic laws of probability, we know that if a set X is a subset of set Y, then so if set X is subset of set Y, then the probability of set or event X is less than or equal to the probability of the event Y. This is true because the event X is contained within the event Y. So by using this theorem, we can prove this inequality. So now let us we can clearly see that the set A intersection B, the event A intersection B, is clearly a subset of the event A. This is true because, for example, if A is equal to, if the event A consists of the following outcomes A1 up to AM, then the event A intersection B will consist of the events AM minus 1 up to AM. So clearly the set A intersection B or the event A intersection B is a subset of original set A. So by using this theorem, we can clearly state that A intersection B, the probability of A intersection B, is less than or equal to probability of A. And similarly, just like A intersection B is a subset of A, it is also a subset of the set B, the event B. Therefore, we can apply the similar inequality for these two events. That is, probability of A intersection B is less than or equal to probability of B. This is true because the set A intersection B or the event A intersection B is a subset of the event B. So this is the first theorem and also the second one. Now let us look at the other theorem, that is the next theorem, that is probability of A union B is definitely greater than or equal to probability of A. For this inequality, we use the following definition, that is probability of A union B is equal to probability of A plus probability of B minus probability of the intersection, that is A intersection B. Just now we actually derived that the probability of B is always greater than probability of A intersection B, that is this part is always greater than or equal to 0. So, and we know that from axioms of probability that probability of A union B and the probability of A are all greater than or equal to 0. So when you add a positive term, a non-negative term to a positive term, we get a positive term. And since P of A union B is equal to probability of A plus a non-negative term, say alpha, which is greater than or equal to 0, then we can definitely say that probability of A is less than or equal to probability of A union B. In other words, probability of A union B is greater than or equal to probability of A. That is this inequality. Along similar lines, we can easily prove that probability of A union B is greater than or equal to probability of B by just using the theorem 1, that is the inequality 1. Thanks for watching.